Alright, let's continue talking about this photoelectric effect. The idea is shine light on metal, electrons pop out, and so naturally, some scientists figured this out. They wanted to take some measurements and develop some procedures for figuring out how much energy electrons can have. So let's say we have some parallel plates here, and we're going to shine some light on it, and in a successful experiment, maybe knock some electrons off at all different speeds, and we want to get a measure of the energy of these electrons. So one way to do that is by taking its energy away in a very controlled fashion. So let's say we want these electrons, which are zipping in all different directions, maybe some of them are heading to the right, we want to slow them down, take all their energy away. So let's say I want to charge up these plates. Which way should the plates be charged so that as the electrons are heading to the right, they'll lose energy? In other words, which plate should be positive, which plate should be negative? Just pause the video and write it down for whichever, label the plates. Okay, so hopefully you figured out it's going to be like this, right? You want the electrons to slow down, lose energy. They don't want to go by the other negative plates, and so they're going to slow down by doing this way. So positive on the left, negative on the right. So we'll attach a source of voltage so that the positive terminal is over here, connected to the positive plates here, and then this one's going to be connected to the negative plate, but we want a way to register whether or not these electrons made it there. So what we'll do is we'll add an ammeter in here, so that if electrons have sufficient energy to get there without being slowed down too much, they'll register as a current through here. And so the idea is what we're going to do is we're going to turn up the voltage on this. Maybe it's like a lab volt, and we turn up the voltage provided by it until the ammeter reads 0. Once the ammeter reads 0, we've stopped all the electrons going across there. And so let's label the plates here. The negative plate, of course, will be the low potential. We'll call that 0 volts. The positive plate will be the high potential. We'll call this V sub S for the stopping potential. So the potential difference here is whatever potential difference is necessary to stop the electrons, take all their energy away, so that the current, the ammeter here, reads 0 current. So we can analyze this from an energy perspective, that the electrons are losing kinetic energy by gaining electric potential energy. This is just conservation of energy. And then we'll separate out the deltas. The delta KE, of course, is final minus initial. Before I do this, I want to replace this in terms of the potential difference. Remember, potential energy is Q delta V. Now, remember, the whole point of this is that the electrons will stop when they get to the end. So the final kinetic energy is going to be 0. Delta V, of course, is final minus initial. And the charge, since the electron is negative elementary charge. These are all specifically electrons. They all have one elementary charge, but it's negative, so Q equals negative E. The electrons are starting at this plate and moving over here, so their final potential will be the 0. Here the negatives cancel, the negative cancels this negative. I replace VF with 0. Here I'm changing KE0 to KE max, indicating that when the light hits the positive plate here, the electrons are going off in all different directions with probably a variety of speeds. And so if we tune this until all the electrons stop, we've taken away the maximum amount of kinetic energy they must have, so we're going to call that KE max. And so this negative sign is going to cancel this negative sign, and now we're left with KE max equals EVS, and this is the version of this we're going to box in as a new equation, saying this is the kinetic energy of these electrons, the maximum kinetic energy they could possibly have, turned into electric potential energy, where V sub S is what we call this stopping potential, and KE max is the maximum kinetic energy of these photoelectrons. Photoelectrons aren't special types of electrons, they're just electrons that are produced in this photoelectric effect. They're just plain old electrons.